Once we have implemented our tracking algorithm, we might want to check its performance in terms of how far the estimated result is from the true results. There are many evaluation metrics, but perhaps the most common one is the so-called root mean square error. In the context of tracking, it's an accuracy metric used to measure the deviation of the estimated state from the true state. So let's see how it's computed. At a given processing step, I basically need two values: the estimated state, which is a vector with the position and velocity components, and the real values, that are usually known as ground truth values. The difference between the estimated state and the ground truth state gives me a so-called residual. These residuals are squared and averaged, and finally the square root gives me the error metric. The lower is the error, the higher is our estimation accuracy. Let's see how it works in C++. So I'm giving you a starting code. I want you to complete the calculate RMSE function, which takes a list of estimated states and another list of corresponding ground truth states. It returns a vector with a root mean square error of the position and velocity. Also consider that you have to check for invalid inputs in the case of the two vectors, estimations and ground truths. The estimation vector should be non-empty and it has to be the same size as the ground truth vector. So you will have to use the eigenfunctions to perform all the necessary operations. You might want to subtract a vector from another vector, as in this example. You also can do the coefficient-wise multiplications as here, or you can compute the vector element square root as here.